So, hello everyone. I hope you all are doing good. So, in today's video, we will understand one of the important concept in system designing, which is caching. So, whenever we use large applications like YouTube, Instagram, Netflix, we expect everything to load very quickly. We open some profile, refresh feeds, search for a product or play some video. We see the response basically comes within a few like milliseconds or milliseconds. So, but behind the scene, these applications are serving millions of users at the same time. If the request directly goes to the database and the or the original server, the system becomes slow, expensive, and directly, like we can say, it is difficult to scale. So this is the area where basically caching comes in. So in today's video, we will understand these topic. We will understand like why repeated database work becomes a scaling problem. What is the caching, why it is used, architecture, cache hit and cache miss. We will also understand like TTL, cache invalidations, what are the cache writing strategies, and what are the caching eviction strategies. We will also understand about something like little bit about CDN application, database, Redis caches. We will also check like some real world examples like Instagram, and we will also check like what like when to use. At last we will be able to understand like what to cache, when to cache, and how long it requires to be cached. So this is all about today's video. So first we will start with the problem. So before defining caching, let's first understand the problem, like what is the problem caching actually solves. So imagine like an application like let's take the example of Instagram. So every time a user when he opens a profile, the application needs profile data. Every time someone views post, the application need post data. Every time someone reaches like refreshes the feed, the application needs feed data. So now imagine millions of users are doing same kind of activity at the same time. So if every request directly goes to the database, the database eventually overwhelmed, and latency rises. And as every request uses some resources, so system resources, so the resource cost also increases. So the core idea about caching is very simple. So in caching, we do expensive work once, store the result, and reuse it multiple times. So suppose an application need to fetch product details from our database. The database may need to perform queries, join multiple tables. Result might require to be filtered. We also can filter the data and then return the final response. So if the same product is requested thousands of times, why should the database repeat the same work again and again? So instead of doing the same kind of work again, the idea is after the first request we store the result in caching, or we can say we can cache the result of the first request. Then next time someone asks for the same product information, the application doesn't need to go to the database again and again, and it can simply return the data to the from the cache. Okay, the first request may take some time because the application need to get the data from the database, but after that the data is stored in the cache. So future request can be served from the caching, and then we can say this can improve the system performance also. Next is real life analogy. The library shelf. So in layman term, we can say we can consider the real life example. Suppose we have a library, and that library has a huge warehouse where all the books are stored. So whenever a student asks for a book, the librarian go to the warehouse, search for the book, bring it back, and give it to the student. So this works when only a few student come to the library. But imagine thousands of the student are asking for the same popular book again and again. So if the librarian go to the warehouse every single time, and we can say she may get tired. So what librarian can do at that time, the librarian can keep the most popular book in the to his nearby shelves. And now the student ask when the student ask for the popular books, the librarian did not go to does not go to the warehouse again and again, and the books is because the books she required is already in the nearby shelves. So in this analogy, the students are the users, the librarian is the application server, and the nearby shelf we can say can be considered as a cache, and the warehouse is a database. So the most important point is this: the nearby shelf does not store every book. It stores usually the books those are most popular and for which a student are requesting frequently. So similarly, the cache does not store all the data at the same time. It stores data that is very useful and need to be served to the user frequently. So this is the core idea about how caching works in the real world example. Next is architecture with cache or without cache. So uh, now let us look the system architecture. Basically, without caching, the flow is simple. Basically, the user send a request to the application goes to the database return the data, the application send the response back to the user. So here there is no caching layer between the application and the database. Whenever the user send the request or ask for some data, the request goes to the application basically, and the application goes to the database to return the data to the user. This is simple, but the problem is that every request is hitting the database. Now let's add a caching layer between the application and the database. If the data is available in the cache, the response is returned returned immediately, and only if the data is not available in the the application can directly go to the database. This means most repeated read request can stop at the caching level only. The database now handles fewer requests. The applications become faster. The system becomes more scalable. So this is the core architecture to explain how system works with caching or without caching. Okay. So to understand caching properly, we will understand the two basic terms, which is cache hit or cache miss. So first is your cache hit. For example, a user asks for a profile data. The application checks the cache. The profile data is already there, so the application returns the response directly to the user. So in this case, the database is not touched. So we call it as cache hit because we find the required data in the cache level only. We don't need to require to go to the database or touch the database. So this process is called as cache hit. In cache miss, basically cache miss happens when the requested data is not found in the cache. In this case, the application has to go to the database, fetch the data, store it into the cache, and then return the response to the user. The first request for a piece of data may be cache miss, but after that data is stored in the cache. So for future request can be served from the cache. Next is why cache is faster, basically. So now let's understand why caching is faster. So we understand that a cache a database is powerful, but it does a lot of work. It may need to parse the query, check indexes, read from disk, join the tables, sort the result, and then it returns the final result to the user. So a caching usually stores the final answer, like it is in the ready to use format. Also many caches stores data in memory like RAM. So memory access is much faster than the disk access, or we can say network based database queries. So this is why tools like Redis are fast. Redis keeps data mainly in memory, so it keeps it can return data very quickly. So this is how caching improves the speed. Next is caching can happens at many levels. Yes, when people hear the word caching, they often think of Redis. But Redis is just one type of cache. In reality, caching can happens at multiple places in the system, and you probably use these caching strategies every day without even realizing it. So let's start with the first layer, which is your browser layer. So have you ever noticed that when you visit a website for a first time, it may take a longer time to load, but next time when you visit the same site, it feels much faster. This is because your browser stores things like images, logos, CSS files, JavaScript files, session IDs. So instead of like downloading the assets again and again from the like server, the browser simply keeps these into the like browser caching layer. So this is the example of browser caching layer, which is the first layer of the like caching strategies. Second layer is CDN cache. So imagine you are in India, but the application's main server is located in the United States. If every request, or we can say like every image, video has to like travel all the way from US to India to serve the like user's request. So this may like look very slower, or user can experience slowness in like in the applications. To solve this problem, companies basically use CDNs. So the CDN keeps copies of images, videos, and other static files in the server around the world. So instead of fetching the content from far away servers, basically users basically get it from a nearby location. So doing this the application feels much faster. So this is the like second layer, which is your CDN caching layer. Third is your application cache. So the this is the basically layer where like tools like Redis comes into the picture. So application basically stores frequently like accessed data such as user profiles, login sessions, trending post, product details, and we can say popular search results. So instead of like querying the database every time, the application can serve quickly retrieve this data from the cache. So this is the like application caching, which is the third layer of the caching. And the final layer is your database layer. So every database try to optimize its performance by caching frequently used data internally. So they keep commonly accessed information in a memory. They don't have to read it from the disk every single time. So this is the like a database caching. Next is, now let's talk about Redis. So Redis is basically fast in memory data store that is commonly used for caching. In typical systems, Redis sits between like application server and database. When the application needs data, it checks the Redis basically. If the data is available, Redis returns it immediately. If not, the application fetches the data from the database and stores a copy in Redis, so the future request can be served. So because the Redis stores data in memory, it can respond much faster than the database. It is commonly used for like user profiles, login sessions, or like popular search results, data like feed data, and other like information that is required to be accessed frequently. So next is one of the most important caching pattern, which is cache aside. So like the cache aside pattern, basically we also call it lazy loading, is a like a caching strategy where yeah, like your application code manages the data flow between the cache and the primary database. So let's understand the flow, like how it works. So there are basically mm, two ways how like cache aside works. First is like cache aside reads in this when the application needs the data, it follows a simple conditional flow. First is the application checks the cache first. If the data is found, it is like used immediately. If the data is not in the cache, the application queries the data from the database, saves a copy of the retrieved data into the cache for future requests, and returns the data back to the user. Next is your cache aside cache cache aside write update the source, then delete the old copy. So when in this strategy, when data changes, like for example create, update, delete, the application modifies the primary database first, because it is the like source of truth. To prevent the cache from serving old information, the application usually invalidate basically delete the corresponding caching entry, and so the next read triggers a cache miss, and then fetches the updated data from the actual database. So here in the read strategy, we are first checking the caching, and then if data found in the cache, we serve the request to the user. If not, we check the database and find retrieve that the required data and update the cache first, because data is not found there in the cache, and then serve the request to the like database, to the user. While in we can say like a writing strategy, we try to keep our like source of truth, basically the database, updated, and then delete all the we can say all the information to make the cache invalidate, so that the every request first go to the like database, and then from that database the caching layer is updated first, and then the request is served back to the user. So these are the two basically we can say the two strategies of caching, basically caching aside patterns. Next is your TTL, balances faster, TTL. Okay, TTL and cache invalidations. So now uh, like one of this is the one of the most important part of the caching. So storing the data in caching is easy, as we all know, but keeping that cache data updated is like the real challenge, because the cache is only a copy of the original data, so the real data is still stored in the database. So whenever the original data changes in the database, we need to make sure the data does not keep showing the old values. So this is why TTL and cache invalidation comes in. So TTL means time to live. So it decides how long a value, or like we can say the data, should stay in the cache before it automatically expires. For example, trending post may can be cached for 30 seconds because they changes quickly. Product details may cache for 10 minutes because they do not 10 minutes because they do not change very often. Profile data can be cached for 5 minutes. So but choosing TTL is trade-off. If we keep the TTL long, the system becomes faster, but data stays in the cache for a longer time. But the risk is that user may see the old data. If we keep the TTL short, user can get the fresh data, but the system has to go back to the database more often, which increases the database load. So it's all about like finding the right balance between speed or freshness of the data. So we need to check what we need to decide what should be the TTL of the data. Next is cache invalidation. So suppose a user updates their profile picture. The data now has the new profile pictures, but the cache may still have the old profile picture. So if the application returns the data from the cache, so the user may see the old images. So this is called as we can say the data is not fresh. The speed is there, but data is not fresh. To solve this problem, one of the common approaches, first we will update the database, because that is the source of truth. Then we will delete the data from the cache, because there is the old data, or we can say the data is not fresh. Now next time someone requests for the profile, or we can say the application application first check the cache, and then the data is not found in the cache, then it will fetch the data, latest data from the database, store its new version in the cache, and then basically return the response to the user. So this is why TTL and cache invalidation are important. Next is write strategies, balances freshness, speed, and risk. This is same as I told you. We have three strategies. First is cache aside write, cache aside read. Then we have write through and write back. These are 3-4 strategies we basically use. So first is cache aside write. In this approach, basically when the data changes, the application updates the database and then deletes the cache key, as I explained you earlier. The next read will fetch the fresh data from the database, refill the cache, and then serve the data back to user. Second strategy is write through. So in this strategy, basically data is written to both cache and database all together. The advantage is that cache stays fresh. The disadvantage is that write may become slower because we are writing at the both places. Third is your write back. In this strategy, we basically we are writing the data cache first, and then later writing the data to a database. So like this can make writes faster, but it is riskier because we are not updating the source of truth first. We are updating if there is any cache fail before the data is written to the source of truth, which is your database, the data may be lost. So this is the third one. Write back is is usually not the best choice when you are writing the data into the cache or databases. Third, next is your eviction keeps limited cache memory focused on useful data. Okay, so here we will talk about like cache evictions. So cache memory is limited, we all know. So we like cannot store everything in it forever. So at the same time the cache becomes full, and uh, like when the cache is full, then the system has to decide like which data should stay and which data should be removed. So this process is called as cache eviction. Like when the data like cache is full and we need to write the new data into the cache, then we need to decide like which data needs to be like keep into the cache, or which data is older, or we can say which data is least required, or that needs to be like evict from the cache. So this the whole process of evicting the data from the cache is called as cache eviction. So there are two common ways to remove the data from cache. First is your LRU and second is your LFU. So LRU is your least recently used. So basically it removes the data from yes, it removes the data that is not being used for a long time. For example, it has three if the cache has A, B, C data, and A was used recently, then when a new item D needs to be added, the system may remove B, if B is not used for the long time. So this is like how in this approach in LRU we basically check which data is least recently used. Suppose ABC. In ABC, the like last accessed time, or we can say the least recently used data is C. Then it will evict the data C and entry of C, and add the new item to the cache in place of C. Next is your LFU, which is your least frequently used. So if in the above case LRU, we were checking the least recently used, and in LFU we are checking like which is the data which that is like least frequently used. For example, we have A, B, C. Suppose A is accessed 100 times, B is accessed 20 times, and C is accessed only 3 times, or we can say like vice versa. So we will check which one is the like least frequently used entry. Then we will consider that least frequently used data, consider it as a best choice for removing. So the difference is simply LRU checks when the data was last used, and LFU check how many times the data was used. So these are the two cache eviction techniques. Now let's answer a very important question. What should we actually cache? So first is your we will understand about what to cache. In general, the best data to cache is the data that is requested again and again, but does not change very often. For example, user profile, product details, or we can say category pages, search suggestions. So these are the data that is we can say um, uh, these are the data basically those we are accessing frequently. So these kind of data is required, is considered as the best choice for caching. Second is cache carefully. So every type of data um, is not required to be cached in the same way. Some data need extra care because it changes very often, and it must be very accurate. For example, prices, inventory count, like count, view count, notification count, and permissions data can be like cached, because but we need to careful with the freshness, because these data is very vulnerable to the changes. If inventory data is old, a user may buy a product that is actually out of stock. If the permission data is old, a user may get access to something they should not access. Okay. Third is avoid casual caching. So some data is even more sensitive, like payment status, bank balance, authentication secrets, or authorization decisions. So this type of data are not mean to be cached, or should not, or we can say should never cached, because it means we need a very careful design before caching it. So this is the basically example of Instagram style feed. which is using multiple caching layers. We have CDN, where we are storing images, videos, reels. We have Redis, where we are maintaining the sessions, profile, popular post related data, which is like a fast shared state. We have feed cache, where we are like caching the feed data, and we have counters, where we are updating the likes, views, background updates. So this is basically the high write volume. Next is your common caching problems. So the first problem is stale data. This happens when the cache returns an old value, even though the data has newer data. So second is your cache stampede. Imagine a popular cache key expires. Suddenly, thousands of requests arrives at the same time, so all of them miss the cache and hit the database altogether. So this can overload the data. The common solution is like a request coalescing, where only one request rebuilds the cache while other waits and or we can say use slightly stale data. Third is cache penetration. So this happens when a request repeatedly asks for the data that does not basically exist. Fourth is your cache avalanche. So many keys expires together and traffic floods the DB. So this is basically that. So the final takeaway, we can say, caching is not just like storing the data somewhere to make the system faster. Caching is a system design decision. Basically, it is about understanding which data is expensive to fetch, which data is requested repeatedly, which data is required to be served as a fresh, how to serve it quickly without breaking the correctness. So we need to understand what to cache, when to cache, and where to cache, and how long the data needs to be cached, and how to invalidate the cache correctly, and then understand caching at a real system design level. So this is all about today's video. If you like my videos, please if you have any question, you can write down in the comments. I will try to do R&D about that and answer your questions. If you like my videos, please like this video and subscribe to the channel. Thank you.